Assalamu alaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. Children will continue with number systems. So actually what I'm going to teach you today is the most important part. Okay, I mean you will be using these things whatever I'm teaching you for your 10th standard. So the first session had just a simple introduction about the real numbers, that is the rational and irrational numbers, but here we are going to learn about operations on real numbers. Okay, see, when we say in mathematics, when I say operations on real numbers, it means addition, how to add, subtract, multiply, division. These are the operations. Okay, so we are going to learn how to add, multiply, subtract, divide a rational number. Okay, so see, you have to follow a few rules. So if you have a radical, okay, a root, okay, so if you have root of ab, let's say a and b are some numbers, some real numbers. Okay, if you have root of ab, this could be separated as root a into root b. Like if I had root of 6, okay, I can actually write it as root 2 into root 3, or root 2 into root 3 could be just written as root 2 into 3 also. Understood? So that is what the first option says. The second thing says the same thing goes for division. So if I have 5 over 4, I can write it as root 5 over root 4. Okay, so I can separate this, I can break the root, that's all. Alright, now if I have this root a plus root b and root a minus root b, I will be getting it as a minus b. See children, we have learnt in our previous in our sessions before, that if you have two numbers like a plus b and a minus b, you can write this as a square minus b square. Okay, this is the formula you would have learnt in your 8th grade actually. So if you have root a plus root b and root a minus root b, you can actually write it as root a square minus root b square, and when you square it, the root goes off, and the root actually goes off from the root a, so you get simply a, and from the root b it goes off and you get simply b. Okay, so the root and the 2 gets cancelled. Understood? So now if you have a plus root b and a minus root b, so again the same thing, a square minus root b the whole square. So that's going to give you a square, because a doesn't have a root, so it will come as a square, and b has a root, so the square goes off and the root also goes off, so you simply get b. So that's how you get this. Okay, now coming to the next option, next thing, identity. So if you have root a plus root b and root c plus root d, so two different terms, so you simply multiply. So what do? You multiply root a and root c, so root ac. Then you multiply root a and root d, so root ad. Then you multiply root b and root c, so root bc. And you multiply root b and root d, so root bd. Okay, so normal multiplication, how we have learnt in our earlier classes. So now root a plus root b the whole square is going to be, it's going to follow the rule a plus b the whole square formula, which is a square plus 2ab plus b square. So if I have root a plus root b the whole square, I will be writing root a the whole square plus 2 root a root b plus root b the whole square. So root a the whole square becomes just simply a. Okay, as I told you, when you have a square, the root and the square gets cancelled, and here you get 2, and a and b both are having roots, so I can write them inside. 2 root ab plus b, root goes off. So this is how you get this. Okay, so now as you can see, we are going to do examples based on this. So if I have 2 plus root 3 and 2 minus root 3. So this is of the form a plus b, a minus b formula. So you have a plus root b, a minus root b is going to be a square minus root b the whole square. So a square minus b is the answer. So you get, so in here instead of a you have got 2, instead of b you have got root 3, right? So you will be writing a square, which is 2 square, b square is just, b is just 3. So 4, 2 square is 4, 4 minus 3 is 1. So 1 is the answer. Okay, so now we'll move on to 5 plus root 2 the whole square. So it's of the form a plus b the whole square formula. So I will be writing a square plus 2 a b, instead of b I have root b, so root b plus root b the whole square. So I get a square plus 2 a root b plus b, because the root goes off. So now I have to substitute 5 for the a and root 2 for the b wherever I have. So a is 5, so I put 5 square, 2 into a is 5 again, b is root 2, and b is 2, right? So b is 2, not your root, just saying b is 2. Okay, so here you get 5 square is 25 plus 2 5s are 10. 10 root 2 plus 2. Okay, so 25 plus 10 root 2 plus 2, which is going to give you 25 plus 2 is 27 plus 10 root 2. Okay, so this is how you add this. And you can't add this, you can't write it as 37 root 2 because root 2 is a different thing. Okay, see, these two are not like terms, they are unlike terms. Okay, you can't add them, they are unlike terms. See, one is having a root 2, the other one is not having a root 2, so you can't add them. Alright, so now see, I'll just show you how to add this. 5 root 3 minus 2 root 2 plus 6 root 3 plus 4. Now here you see the 5 root 3 and the 6 root 3 have root 3 in the with attached to them, so they both are like terms, so you can combine these two. The other two are unlike terms, so you keep it separately. Negative 2 root 2 plus 4. Okay, so these two can be added. So 5 plus 6 is 11 root 3 minus 2 root 2 plus 4. This is the answer. You can't do anything further. Okay, you'll have to stop here. Now we will learn how to rationalize. So there's something called as rationalize. So remember, whenever you are solving a problem, you should not leave the answer with the root in the denominator. So denominator should not have a root in it. Okay, so what you should do is, I have 1 over root 3. So to get rid of the root 3, I will multiply by root 3, because root 3 into root 3 is going to give you simply 3, right? So anything multiplied, you know, any root multiplied twice is going to, you get rid of the root. See, you get root 3, the whole square is this 3. Why does this happen? Because root 3 into root 3 is actually root 9 and square root of 9 is 3, right? So the same thing happens for root 2 also. Let's say root 4 into root 4 is going to give you simply 4. Root 5 into root 5 is going to give you simply 5. So I will I have to make the root 3 as 3, so I'll have to multiply it with another root 3. But whatever I do, I'll have to do it on the top also. So now I have 1 into root 3 is root 3, and the root 3 into root 3 turns out to be simply 3. So root 3 over 3. Okay, so now what if you had two numbers like this in the denominator? Okay, so then what you should do is, the method is little different. You should not just multiply by root 3 here, because there is 4 plus root 3 over here. Okay, so you will multiply with the conjugate. You call it as conjugate actually. You don't have to worry about the term actually right now. So what you should do is, you multiply by 4 plus root 3 is there. You have to multiply by 4 minus root 3. So whatever is sign over here, you will have to change the sign and multiply it. The 4 and root 3 will be the same, but if there is a plus here, you will multiply with a minus here. If there is a minus, you will multiply with a plus. Okay, so the same minus you will multiply on top also. Okay, so now 1 into 4 minus root 3 gives you just 4 minus root 3. At the bottom you can write, see, it's of the form a plus b, a minus b is going to give you a square minus b square. So 4 plus root 3 and 4 minus root 3 is going to give you 4 square minus root 3 square. Okay, so 4 square, so that's what I have written. So 4 square will remain as 4 square, which is 16, and root 3 square is going to be simply 3. So you get 16 minus 3 at the bottom. On top you will have 4 minus root 3. At the bottom you get 16 minus 3, which is 13. So on the top you can have a root. That's okay. But the denominator should not have a root. So this process is called rationalizing. Okay. So they may ask you to rationalize. So this is how you have to do it. Now let's rationalize this particular problem. 1 over root 2 minus root 5. So I'll multiply by, see, there is a minus, right? So I'll multiply by a plus. And same thing on the top also. So the root 2 plus 5, root 5 comes as it is, and here at the bottom you will have root 2 square minus root 5 square. So that's going to give you 2 minus 5. So that's going to give you minus 3. So root 2 plus root 5 over minus 3. This is the answer. Or you can simply write negative root 2 plus root 5 over 3. This is also okay. I mean, you know, you're writing the minus sign or the bottom or on the top doesn't matter. Okay, so now from this exercise 1.5, solve question number 1, 2 and 5 alone. Okay, the rest you can just skip. We don't have to do that. Okay, now coming to the next very important thing, laws of exponents. So do you understand what an exponent is? So exponent is like if I say 2 to the power of 3, for example. This 3 is what is called as the power. Okay, or this is also called as an exponent. Okay, so we are going to learn what are the properties of this exponent. So if you have two numbers, okay, let's look at this, a to the power of m times a to the power of n, then you can actually write it as a to the power of m plus n. So I will give you one example. Let's say I have 2 to the power of 3 and 2 to the power of 4. I can see the twos are same, right? See, this happens only when the twos are same. Look at the twos, the base is same. This is the base has to be same. The exponent could be anything. So if the base is same, you can just write it as a single base and add the numbers. So when it is multiplication, the powers get added up. Okay, so that's your first option. And the third option coming over here, it says when it is division, let us say you have 3 to the power of 5 over 3 to the power of 2, for example. So if this is the case, now here you see 3 is common, the 3 is base, the base is same. So you can subtract it, 3 to the power of 5 minus 2. Okay, so when it is multiplication, the powers get added up. Okay, and when it is division, the powers get subtracted. And what will you subtract? You will not do 2 minus 5, you will do 5 minus 2. So the top one will get a positive sign, the bottom one, in front of the bottom one you will put a minus sign. Okay, so that is what it says. Now here come to the next second option over here. It says a to the power of m times n is a to the power of mn. That is, if I have 2 to the power of 3 and let us say 4, I can write it as 2 to the power of 3 into 4, 12. Okay, so here if it is inside the bracket and outside the bracket, if the powers are one inside the bracket and the other one is outside, I can multiply both the powers and write 12 as a common the same power. Okay, and similarly if I have, let us say I have 3 to the power of 5 and 2 to the power of 5. Now you see what's happening, the powers are same but the bases are different. So I can actually multiply the base 3 times 2, which is 6 to the power of 5. Okay, so that is what your fourth option says. Alright, now we'll do few examples. So see, look at this. If you get 2 to the power of 5 over 3 and 2 to the power of 2 over 5 and multiplication is there, the 2 is the same base, so you can just write 1, 2 once and then you add the power. So 5 over 3 plus 2 over 5. So this 2 will be remaining in the base, and in the power what happens, you'll have to make the denominators common. So multiply this by 5 and this also by 5, this by 3 and this also by 3. So by doing this we are making the denominators as 15. So I get 25 by 15 and 6 by 15, right? So then you can, since the denominators are same, you can add the number. So 2 to the power of 25 plus 6 divided by 15. So 31 by 15. Okay. So now come to this problem. Let's say you have 3 to the power of 4 by 3 to the power of 7. So it's division. So I will write 3 to the power of 4 minus 7, which is equals to 3 to the power of minus 3. Okay. That's the answer. Now if you have something like this, 5 to the power of 2, and then inside the bracket, outside the bracket you have 3 over 4. So this 2 and 3 over 4 actually gets multiplied. So now you see you can simplify. 2 ones are 2 twos are. So you can directly write 3 over 2, or you can multiply, like 3 twos are 6 and 4, and then you simplify it. Okay, either way, see, 2 twos are 2 threes are, either ways you can do it. Okay, now if it is two different numbers with the same power, I can just write 6 into 5, the whole thing to the power of 3, or 6 fives are 30 to the power of 3. That's it. Okay, so now this whole exercise is whatever I have taught. So this whole exercise comes from that. So you can just finish this exercise in your classwork. Okay, Allah Hafiz. That's all. This chapter is over. So see you in the next video. Allah Hafiz. Thank you.